Welcome to the first of 6 labs on error detection and correction. In this lab, we'll focus on detecting errors using the concept of parity. In this lab, we'll look at parity on ASCII bytes. Anytime that digital signals are sent or received, there's the possibility of a bit error. There are several options that exist for dealing with corrupted bits, and we're going to explore them in this lab series. These 6 labs will demonstrate several ways for detecting, and we'll look at some ways for correcting errors in later labs. The labs will also give you practice with C programming, and also introduce some basic data structures and algorithms. There are a number of applications that require error detection and correction schemes. They include data transmission over the internet, data storage, so things like RAM have this sort of error detection mechanisms, credit card verification like CRC codes, and any other applications where integrity of data is important. It's important that we define what we mean by error detection and correction. Detection is the ability to identify data that may be corrupt, but we don't have the ability to correct that data. That's where error correction comes in, where you can both identify and correct for corrupted data using some sort of redundant information that has been supplied. And what we mean by redundant, usually we mean repeated information. So error correction algorithms use redundant or extra information that's supplied with the original message. The process of adding this extra redundant information is known as channel coding. Channel coding has been used in memory subsystems. It's one of the simplest ways for detecting single bit errors. For example, typically every byte has 8 bits. However, in some older memory subsystems, they had 9 bits, and the 9th bit was used for parity checking. If a parity error was detected, then the operating system would shut down. You may have experienced the blue screen of death, and there's an image at the bottom of the screen that shows something like this that can happen. So what is this parity checking, and how does it work? Well, effectively, the system chooses whether or not it wants to have even or odd parity. So, if the system chooses even parity, then what it does is it sets that parity bit so that the total number of ones, in a set of bits is even. If the system is chosen to have odd parity, then the parity bit is set so that the total number of ones is odd. An example might illustrate this a little better. P is the parity bit. That's the 9th bit in a group of 9 bytes. So 8 bytes of data we call the payload, and then the 9th bit is that P. So if the system has even parity, how many bits are in that number? So we have 1, 0, 0, 0, 1, 0, 1, 0. 3 bits are ones. So if we want to have even parity, if the system has chosen even parity, then that one bit must be set to a 1. If the system is set to odd parity, then that 1 bit will have to be made a 0 so that we have an odd number of ones in every number. So, in a system that uses parity, if there's a single bit that changes state, that would indicate an error in the data, then the parity will change and the error can be detected. For example, if we have a sender and receiver, Okay, and the whole system both are using, they have to choose. Are we going to choose even or odd parity? So let's say that they both choose odd parity. Okay, so imagine that the sender wants to send this binary number 0110 1101. Okay, so there are 5 ones. So if they're using odd parity, the parity bit must be set to 0. Okay, so they transmit that number, and just imagine that the third bit changes state. What happens there? 4 ones will be received by the receiver. Because that's an even number, not an odd number, the receiver will know that an error has occurred. Note, however, that if there's an error in the parity bit, the receiver will also detect a parity error. Channel coding with parity does have its limitations. Any even number of errors, okay, if there are 2 bits in error, 4 bits in error, 6 bits in error, or all 8 bits in error, this will defeat the algorithm and the errors will not be detected. It also doesn't have the ability to indicate which bits may be in error because it can't correct for those errors. The only recovery action in any error is to request a retransmission from the source. Parity, however, is the lowest cost channel coding scheme because it's capable of detecting errors with an overhead of only 1 redundant bit. In summary, channel coding via parity checking uses a single bit to guard a data unit. It can detect an odd number of bit errors. So if there is 1 bit, 3 bits, 5 bits, or 7 bits in a block, a byte, it will be able to detect that an error has occurred. If the unit of data is in bytes, then the overhead of using parity is 12.5%. It's 1 bit in 8 bits. This is called a 9-8 scheme because there are 9 bits in total to encode or protect 8 bits of payload. Before you begin this lab, you may wish to review the following C concepts: pointers, used instead of array indices, function calls, loops, enumerations, using buffer length instead of depending on a terminating null character, static versus extern, creating multi-source C projects, comments and styles, or comment styles, and ASCII versus binary numbers. Your goal in this lab is to write a function. This function is called parity on bytes, and you must use this name as well as the inputs given. You have a pointer to a character array and the length of characters in that array. This is basically a buffer. Buff is a pointer to an array of characters, and the maximum number of characters that can be stored in this buffer is iBuffLen. This protects buffer overflow. Make sure to use buffer as a pointer, not using array notation. The goal here is to practice using pointers. The buffer array is a character array. So instead of storing numbers here in this example or in this lab, we're going to use ASCII characters. So character 1 and character 0. In later labs, we'll convert this to bits. We'll convert this function that we write here into one that operates on bits. So this is parity on bytes, just to get the concepts down. The goal of this function is to basically measure the parity of a given number, which can be of any length. Now this number is going to be entered at the command line. And what's going to happen is, because the numbers are entered at the command line, they will be characters instead of integers. And what we're going to do is we're going to count the number of characters entered by the user. Okay, so if that number is even, we're going to return par even. If the number is odd, we'll return par odd. Otherwise, we'll return par error. For example, if the user does not enter a 1 or a 0, but enters any other character, the function should return par error. The data type that the function returns is of type parity. Parity will be defined as an enumerated data type, and we'll show you the definition on the next slide. For this lab, a main has been provided for you to test your function. Main and the function you will write must be in separate files. Be sure to study main so that you understand what it will do, but you may not change main in any way. On this slide, you will see how you must define parity.h. You'll define parity as an enumerated data type with par even as 0, par odd as 1, and par error as 2. The function prototype may also be defined in parity.h as parity on bytes with the parameters of char, buff, and int ibufflen. If main was called from the command line and the program that we were writing was run from the command line, you could call main and then enter your input arguments, your command line arguments. However, since we're using Visual Studio Code, the way that we enter command line arguments is a little different. In order to enter command line arguments when you click Run in Visual Studio, you have to enter them in the Properties section, or the Properties tab, basically. So what you do is right-click on the project's name and then select Properties, and then go to the next slide. After clicking Properties, a new window will open. Make sure that the configuration says Active and the platform is the active platform that you're using. Under Debugging, click Command Arguments and add the character array, okay, with the 1s and 0s that you'd like as your command line arguments. In the example shown here, my first argument is 1100. Okay, my second argument, because of the space, is 1000. So the first argument should generate a par even, and the second argument should generate par odd in the output. Okay, so to get started on this lab, the first thing we need to do is we need to open up Microsoft's Visual Studio. So here I'm using Visual Studio 2019, but you can use whatever version is the most up to date. So create a new project. Okay, we're going to make a console app right here, and then just go to next. I'm going to call this Lab 1. Lab 1, and where do we want to store it? Let's put this one, I'm going to put it on the desktop here. So we're going to go up to the desktop, and then go, we can actually select this one because it's going to make a folder here. Okay, a Lab 1 project. Okay, and create. Okay, and it's going to open up for us. Okay, so first thing we need, we don't actually want to use this program, so I can go ahead and delete this. Okay, I want to remove and actually delete the file. Okay, and what you want to do is you want to go and download, okay, at least the main file from, you're going to go to your Conestoga here, eConestoga, and you're going to download the main file. Now I already have the main file, so I've already downloaded it, And what I'm going to do is I'm going to copy that into the folder there. So first thing, just give me a second. I got to go and grab that file. Let me see here. Here, 1 second. Let me just grab the file and drag and drop it into the. Okay. Okay. So you're gonna go and I'm gonna copy it and paste it in. Paste it into here, into lab 1. Okay. Wrong folder. That's where I'm copying it from. Copy it into here, and I'm just gonna paste it right into the root here. Okay, so right where the solution is. Okay, then I go over here, and I'm gonna right-click Add. Okay, existing item, and I'm gonna add main lab1.cpp as my existing item. Okay, and this is where the main is included. Okay. Now parity.h is not there, so you're going to see a couple of errors here. Okay. One is so parity.h does not yet exist. We have to make that. So if I right click here and say add new item, okay, and I'm going to create the header file and call it parity.h. Parity.h, say add. Okay, so this is parity.h, but with parity.h, okay, we have, this is the header. We also need the CPP for this, or this .c. I'm using, okay, because I'm using, I'm going to use .cpp because C files can run within C++ files. So, so anyway, I'm going to say add a new item, and this one's going to be a C++ file. Say add. Okay, and I have to I should have changed the name. Instead of source, I need to rename. Okay, and this one's going to be called parity.cpp. Okay, so they're going to come in pairs. We have parity.h and we have parity.cpp. Okay. Now, parity.h was given to us. Okay, so in the lab spec that we just saw, we have parity.h there. Okay, so all we need to do is write the parity.h. Now, Pragma once only works. Okay, this is going to only work in Windows. So what I'm going to do is I'm going to make, when I write my code, I'm going to make a code that can also run in Linux if I want to. Okay, so right here, I'm going to get rid of the Pragma one. So we're going to use ifdefs block to block anything. So space. Like this. This is how you can make multi-line comments. Okay. So what I like to do is I like to put the name of the file, parity.h. Okay, and then underneath I could put a tab here, and then I could say what the file does, right? Or I could put description, and then here I'm going to say it defines enumerated. Okay. Data type. Okay, so parity. I should. Okay, and also it declares the parity on bytes. Okay, and declares let's see, the parity on bytes function. Okay. All right, and here you could put author, right? Okay, so this is how we're going to build our files. I'm going to do the same thing here. So I'm going to go. Actually, it doesn't define it. That's going to be in the other one. I'm going to say declares. Actually, no. This one defines. It defines the enumerated data type, and okay, and it declares parity on bytes. I actually did that right. Okay, so what we want to do, I'm going to take this. I'm going to copy it, go to parity.cpp. I'm going to do the same thing here, parity.cpp. Okay, and here I'm going to say defines parity on bytes function, or the parity on bytes function. Okay, and we're going to save. We're going to go Control S. Okay, and here we're going to go Control S. Okay, or F5 will run it. Nothing. There's no build errors, so everything's okay so far. Okay. There were build errors here, but no problem. There's nothing in the code, so say no. Okay, because the main function calls functions that have not been defined yet. Okay. So let's go to parity.h. We have what we need to put here. Okay, that was provided to us that we in the slides. But what we want to do is we want to make sure that whatever declarations we have here are only declared once. So we're going to use the blocking if defs, so that works like this. So say if not defined, okay, and we just have parity h, okay, right? Then we're going to define parity.h, okay, and then at the bottom here, here's the end if, okay. So it's going to go a bit between these two, define, okay, and end if. Actually, between the if end if and the end if is the this is going to block. It's only going to run once, basically. So enumerated data type parity, okay, and then here we have par even, okay, par odd, and par error. Okay, so these are the various, and this we could say this is our enumerated data type parity. Okay, so we put our comments. Okay, so this is where we define the enumerated data type parity, and then here's where we're going to define our function prototypes. Right? Actually, declare, not define. We're going to declare function prototypes. Okay, this is our function declaration. So we say parity. Okay, so that's the return type. Parity, I spell it right, on bytes, and then car star. So it's a pointer to a character. Some people like to put the star in front like this. Okay, so buff is a pointer. I like to look at it like this. I say this is a character pointer. So buff is a pointer to a character array. It's a character pointer. Okay, and then here is the length of that buffer. So int, and then I buff len. Okay, and then this is just the declaration. So the idea here is that I buff len is the length. So later, what we're going to do is when we have this pointer, we need to reserve memory space. So this pointer points to the location, the first byte in that memory space that we've reserved, and then iBuffLen is the length, right, of memory in bytes, okay, of how much memory we've reserved. And the idea is that by having a pointer to the first and then the length, okay, of bytes that we have reserved in memory, that we don't overflow into other areas of memory that may be used by another program. Okay, so let me go Control S to save. Now here it's telling me I haven't declared anything, right? I haven't declared this, so I have to actually go. So we're done here. We're done with this this file. Okay, so what do we care about? We care now about parity dot cp. So this one actually is, what are we saying? Okay, so this one is the main. Okay, so this is actually main that we're looking at here. Parity.cpp has nothing so far. So what we need to do is in parity.cpp, what we need to do is we need to go in and we need to, first we need to say include, okay, we need to include parity dot h. Okay, and we have to do that again. When you include with quotes here. Okay, so we need to include parity.h and save. Now it knows, okay, that this file is including all the declarations, and now we have to define parity.h. So we're going to go So now we're going to say parity, okay, uh, parity on bytes, okay, and it has to be defined exactly the same way as we declared it, and this was shown in the slides. So we say int iBufflen, and then here is where we define our function, and I like to put here at the bottom end of parity on bytes. Okay, because if you have lots of functions, the blocks, just to be able to see, I know that in VS Code you can see the blocks, but in other IDEs you may not be able to see it. Okay, so anyway, it's good practice just to have it. Okay, so we have the definition and the declaration. If we go into main, you can see that parity on bytes now does not have the error because we have parity.h declared. Okay, so the declarations happen in the header files. The definitions happen in the C or CPP files with the same name that include the header. Okay, and then here is where we're going to define our function. But before we define the function, what I want to do is I want to go and take a look at main lab 1. Okay, and just to see how the function, what it requires. Okay, so let's just go and take a look. So we need standard input output. This is for printing if we need to print. Okay, and string.h, okay, is also because we want to have the string functions like strlen. Okay, so we need that. Malloc is for memory allocation. Okay, so whenever you need to allocate memory, okay, for a buffer, for example, you need to include malloc. Standard library has there's a number of things that we need for the standard library from there, and then parity.h is the header file. Again, it has to be this has to be the name of your header file. Okay, because the main function is already written for you. You can't edit it, so it has to be the same name with the first letter capitalized. Okay, so if you have any errors, might just check that's how it is. Okay, in main we have just some integers, and what we're doing, if you take a look at main, so main takes in it takes in as a parameter whenever you call. If we were to use to compile this, and we have main lab 1, okay, when you type the executable, so main lab 1, and then if you put in, so this requires, this whole program assumes that there's arguments that are provided at the command line. Okay, so argc is the number of arguments at the command line, including the name of the executable. Okay, so that's the number of arguments at the command line. Argv is a pointer to each of the arguments. Okay, this points to, so this is a character array. Okay, a pointer to character arrays. Okay, so if you remember in the slides, we had a number of strings. Each string is an argument. Okay, each string, a space separates the strings, and each string in those space separated strings is an argument. Okay, so the first argument is the 0th argument. Okay, the with the index of 0 is the name of the executable, which would be main lab1.exe or .o, depending on which operating system you're using. Then argv at 1 points to the first argument, the first string, basically. Okay, and I'll show you how this works a little bit later. So, what does this do? This function checks to make sure that if the argument count is less than 2, that means that there are no other arguments, just the name of the executable, okay, is being called, then it's going to print this error, and the user is going to see that, you know, they have to input the as strings, okay, the sequence of 1s and 0s that they want to check the parity on. Okay, in the next lines here, the next block, we have a for block, and what does it do? It loops, okay, through the arguments that are provided at the command line. But it skips over the very first argument. Why? Because that first argument is the name of this file, right? It's mainlab1.exe is going to be the executable. So we start at the argv of 1, okay? And we loop until we hit the total number of arguments that were supplied by the user, and this is just the incrementer. And what we do is we call this function that we're going to write, okay, parity on bytes. We supply the string, so this is a pointer to the string, okay, and this is the length of the string using strlen, and strlen stops at spaces. That's why this works, okay. The string length, and we supply that argument number, so it's going to go from argument 1 to however many arguments we supply at the command line, okay, and then it's going to print the string, and then it's going to tell you if it's even, or if it's odd, or if it's error. So what this is, printf, this is just the string, okay? It's going to say whether it's it's going to be even if RC, so this function, parity on bytes, will return par even, or par odd, okay, or error. Okay, or else it's an error. Okay, it's gonna either return even or return odd. Otherwise, it's going to be an error. Okay, so that's actually what parity on bytes is going to return. Okay, if it's not even or odd, then there's an error because it has to be one of either. Now this right here, okay. So look, this line right here. Okay, so what does it say? For and then the string. So that's this guy. That's the string. Okay. Parity on bytes is, and then the next one is the next string here. So it's either, so this right here, okay, is a one-line if. Okay, is basically what it is. So it's going to be par even. Okay, so if RC is this, then do this. Otherwise, if here, see? Otherwise, then here's another nested if, right? This is another if statement. Otherwise, if RC is odd, you put odd. Otherwise, error, okay, is going to be printed. So you're either going to print even, okay, odd, or error. So make sure you understand this, how this works, okay? This is a nested single line if statement, okay? That's all that's happening here. Nothing special. I mean, you could nest 2 if statements if you wanted to. Okay, just so you understand the code, and then at the end, you can end the program, get car, and return. Okay, so our job is basically to write this function. So we're going to count a string, and we're basically going to, if the number of ones that we have in our string is even, we return par even. If it's odd, we return par odd. Otherwise, we return par error. So how do we do this? How are we gonna build this this function? So what do we need? Well, we need something. We need to count the number of ones, right? So let's make an integer, okay, that counts the number of ones. We'll call it sum. I_sum of 1. Now, how are we going to count the number of ones? We need a for loop, right? So let's make another integer called I, and that's going to be our loop counter. Okay? Then what do? Well, we said we needed a for loop, right? So we have a for loop. Okay? Whenever you write a for loop, you have I equals 0. Okay? And then I is less than some number. We don't know what that is. And then we say usually I plus plus or plus plus I, depending on what we want to do, if we want to increment first or increment later. So we need to loop through something, right? We know that. But what do we need to loop through? Well, we need to loop through this buffer, right? It's a string, right? Because parity on bytes is going to take one string at a time, and the length is already given to us, right? I_bufflen is the length of that string. So really, well, our loop has got to be less than I buff len, right? We know this already, right? So while I is less than I buff len, we're gonna go through that string one character at a time. Okay, so that's fine. But the next question is, how do we advance? How do we go from the first character in the string, right? So look, so so buff is a pointer to the first character in the string, right? So we need to advance buff at the end, right? So we could say buff plus plus. Okay, so at the end, once we're gonna look at the first character, is it a 1 or a 0, and then we're gonna go to the next character. So we need this buff plus plus here. Okay, what else? Or another thing we could do, if we don't want it here, okay, what you could do, this means increment after, right? Which is the same thing as what's going on up here. So what we could do is we could put a comma here, just so you know, okay? And we could just say buff plus plus. So this will increment at the end, at the next loop, just like I, right? I starts at 0 at the end, it's increments. So we don't actually need it inside the loop. So now what do we do? Well, now we need to understand. We need to look at what is stored in buff. This pointer here that's supplied at the top here. Okay, so what do? We have to look at what when you want to look at buff. So what's the difference? Now we have to understand what the difference is between a pointer buff, okay, and star buff. Okay? This is the first thing that you need to understand, and the most important thing that people get tripped up on. Buff stores the address, okay, of what's it's basically the address where that memory location is. Okay, it's the address of where the stuff is stored in memory. Okay, it's the memory location. This is the memory location. Okay, and if you dereference, this is called dereferencing. Okay, with the star in front of buff, what you're saying is what's stored at this memory location. Okay, so that's the key. So buff is an address. Think of it like hex, I don't know, 111 A5 or 5556, right? This is the memory address, and inside there, you might have the character 1. Okay, right? So this is the memory. If you look in memory, there's a memory. This is an address in memory. This is what's stored in that address. Okay, address, dereference that address. Okay, so that's what we're doing. So what do we care about? Well, we care to look at that memory location. So we're going to say if whatever is that first character, right? Because buff points to that first character. If buff equal, right? If it equals 1, then what do? Then we need to go in and we need to increment the counter, right? The counter isum. We have a counter, right? Right. If the sum is going to be even, then we're going to say part even, right? The parity is even. If the sum is odd, the parity is odd. So that's the first thing we need to do. So if it equals 1, then what do we need to do? We need to increment I sum. So I sum, right, equals I sum plus 1, right? Now, this is the old way of doing it. This is a simple way of doing it, but a faster, more compact way of writing this same thing would be I sum plus equals 1. That's one way of doing it. Or, even faster, we just say I sum plus plus. Right? Just increment that counter. Okay? So this means increment by 1. Okay? So then, what do? Well, else, right? E-L-S-E. If what's stored there, okay, does not equal. So it's got to be either a 1 or a 0. If it's not, okay, if what's stored in that character is not a 0, then immediately we know there's a problem. And we want to actually stop all further execution, and we want to return, because we don't have to go through the loop. We don't want to do any more work. Return par error. Now, this is an option. This is, see, because the type is parity, we defined in here, in parity.h, we defined par even, par odd, and par error as options. So here we're going straight to return, because it's the parity type, return par error. Okay? So this is if that first character or any other character is not, okay? So this is if it's a 1, increment. If it's not a 1, check if it's a 0. If it's not a 0, then return error right away. Okay? So that's how it works. I like to keep my spacing like this. I like to show my okay, sometimes it forces you into, okay, so that's that. Now what's next? Well, that's our for loop, right? Our for loop is done. So this is going to take us through the string. Okay, so it's going to go through the string, and our output, really, what we're looking at is isum. Okay, so the next thing we need to do after we go through the entire string is check, is that sum even or odd? So how do we do that? Well, I don't know if you've ever seen the mod operator, and the mod operator is the remainder, right? So think about this. Think, okay, what's 6 mod 2? So it's basically the remainder of 6 divided by 2. Is there any remainder? It's 3 remainder 0, right? So 6 mod 2 equals 3 remainder 0, right? Okay, so mod, actually 6 mod 2 is just 0, right? So 6 divided by 2 equals 3. 6 mod 2 would be the remainder, right? It's 3 remainder 0, right? So really, when you use mod, you're looking at the remainder. So 6 is even. Let's try that with 7. Mod 2, or divide by 2, sorry, equals 3 remainder 1. So 7 mod 2 equals 1. Okay? So what do we know? We know that if the result of a mod operation equals 0, it's even. Okay? If the result of a mod operation is 1, then we have odd. Okay? A mod when we mod 2. Okay? Whenever we mod by 2. That's the idea. Sorry. Okay? So, what do? We take isum. So we say if isum mod 2, okay? If it's a 1, then immediately we know we're going to return, say par odd, right? Else, they like to put it that way. Okay, that's fine. Return par even. See, we took care of the error, okay, right away. If it's not a 1 or a 0, this guy's going to return, and it's going to give us the error. I don't like it like that. I want it like this. Okay. All right. So Control S to save all. Actually, let me just save some space here. Control S. Okay. So now we have our function is written. But what's going on here? Enumerated data type parity. The enum type parity is unscoped. Prefer enum class. Oh, class, that's a C++ thing. So what that means is because we're using a CPP file, it's looking for scoped, so class-based enumerated types. But we're writing C code, so this is perfectly valid. So don't worry about this error. You might actually see it. Where else will you see it? You might see it somewhere else. Anyway, it doesn't really matter. We are this is not an error for C code. Okay. All right. So that's fine. And okay. So now, if we were to try to run this, I'm going to show you what happens here. If I try to run it, I haven't supplied any command line arguments. Okay, so it's gonna throw an error for sure, because I just want to show you what to look out for and what you'll see if there's no command line. You see? Usage parity, we didn't supply string 1 or string 2, okay? Because we didn't do this from the command line, we're running it right from inside VS Code. We didn't supply any strings, right, to check the parity on, okay? So what we got to do is we got to actually go in and write, put those strings inside, okay? So let's go here. So how do we do that? We follow what I showed you. So go to properties, so right click on the name of your project, go to properties, go to, where was it? Debugging here. Then go to command arguments. Okay? So here is where you put your space separated strings. So first thing I'm going to do, I'm going to give you one that I know is going to be, so this one is going to be even. I don't know, it doesn't matter what the length of your string, as long as they're separated by spaces, you're okay. So this one is even because there's 4 ones. Okay, I'll do it in bytes. Okay, so this one's going to be 1, 2, 3, 4, 5. This should be odd. 6, 7, 8. Okay, it doesn't matter what the length is actually. I can make it, whatever I want, like that. Okay, and then the next one I want to make an error, so I'll just put X, and then 1, 2, 3, 4. It should generate the error right away. Okay, so now I say okay. Now when I run it, I have to see even, odd, error. Okay, so that's the output that I'm expecting. So now when I run, okay, even, odd, error. That's okay, and that's it. Our program is complete, and that's the end of this first part of the lab. But what I'd like to do is I'd like to show you some other things in this lab. Okay. Okay, so because this lab is pretty short, what I'd like to do is show you how to develop command line programs, and we're going to show you in Windows, and if we have some time, I'd like to show you also on the Linux side. Okay, so first thing we want to do is go online in Econestoga, and what you're going to find is you're going to find a document. There's 2 documents. Okay, development of so it's VS Code and MinGW with MSys for development in Windows. Okay, there's a version 2 on there, and there's also another one for Linux. And what we're going to do now is I want to show you first how to set up. So VS Code is another. It's sort of like a code editor, plus it can also be turned into an IDE. So there's Visual Studio, and then there's Visual Studio Code. Now, VS Code is cross-platform. So when I show you how to set up VS Code in Windows, you can also do so in Linux. And one of the goals in this course is cross-platform development of C applications. Okay, so I'm going to show you how to do this, and we're going to follow along. I'm going to do step by step through this document. Okay, so let's do that. Let's first thing I want to do. So basically, we have lab 1 already done. Okay, so now what we're going to do is we're going to take this and we're going to set up our to run it from the command line. Okay, so let's do that. Okay, so let's follow along in this document and set everything up. So what I'm going to do is put this on this side, recording the screen too. It says this document will show you how to set up your Windows system to build projects using VS Code with MinGW. Okay, MinGW with MSys. VS Code is cross-platform, so Windows, Linux, Mac. And minimalist GNU for Windows is something that we need in order to run these things. We're going to get GCC and G++ compilers. Okay, so this is for command line compilation. For Windows, MSys ports some of the Linux terminal commands to Windows so that we have those commands that we can use. Basically like list ls and other commands that you'll learn about Linux. Okay, so what we need to do, we need to go and install Visual Studio Code. I've already kind of done this, so I have it, but let me just go through the steps for you. Okay, we're going to do them with you here. So just go VS Code, and you're going to install it. So you're going to download it. and you're gonna get it for Windows. Okay, so just go with the download, download VS Code. Okay, I'm gonna stop the download. So cancel because I've already done it. So you're gonna go through the installation steps. Just use the default settings. Okay, and then once you've downloaded and installed it, the next step is go into. So you can open up VS Code. Okay, so open up VS Code, and I'm gonna put it on the side here. Okay, I have to close this. I have some things open here, so I'm gonna close the folder, and we're gonna go just straight into it here. Okay, so what we need to do is within Visual Studio Code, we need to install the extension C++ Project Generator. This is going to help us. Okay, so we need our extensions. Now the ones I have it's this guy right here. So you're gonna search for this. You're gonna search. You're gonna say C++. You type that in, and you might want to take Project Generator because this will help you. PROJ. Okay, and then you're going to search, you click this one, and then you click install. Okay, so we want that. This extension, it's going to organize your files into a project just like in Visual Studio, and it's going to basically it's going to generate a make file for you. So you don't have to worry about make files. You'll learn about make files as well shortly, but it's just easy for a beginner to just use this for now. And basically you're going to be able to make multi-file projects from the terminal. Okay, so we're going to do that. So install this guy. That's the next step. We need MinGW. Okay, so you're going to go to SourceForge and look for MinGW. So I'm going to close this for now for a second, and go to SourceForge. Just go MinGW. Okay. And you're going to download this guy. Okay. Okay, you're going to go to the MinGW minimalist new for Windows. And you're going to go to download. Okay, and then you're going to install. Okay, I already have it installed, but you're going to go to download. You're going to install. Let's just do it here, just for because this one is a little bit more. You got to go through the steps here. Okay. Okay, it's got the installer. I'm going to go to the folder, go in, and I'm going to run it. I've already got it installed here, but anyway, continue MinGW. Use the same defaults. Mine's already installed. Okay, so I'm not gonna go through the steps here, but I'm gonna say quit here for now. And I'm just going to show you what steps to follow once you've installed it. Okay, you're going to go in, and what you're going to click on. Okay, so once you install, during the installation, you're going to click on MinGW Developer Toolkit. You want that. You want MinGW 32 Base, MinGW 32. You want GCC and G++. Okay, and you want MSys Base. Okay, these are the four things you want to install. And then you make sure that you hit apply changes. Okay, so under installation, apply changes. Okay, and then in order to actually use all this, okay, you got to modify your path. Okay, so the way you do that is so like GCC, G++, make, etc. What you need to do is you need to add the location of these, okay, to the Windows path. Okay, and it says here, go to Control Panel, System and Security. So let's do that. So go here, on the magnifier, go Control Panel. Okay. Then you're going to go to System and Security. Then we're going to System. So System. Then Advanced System Settings right here. Then we go to we want to go to Environment Variables. So right here. Environment variables, okay, and then select path and then click edit. So let me put this here. So now we're gonna go here. You see here, down here, environment variables, right here. It's actually already here. Okay, these are these are your user variables, okay? And these are the ones that we need to edit. You see path right here. This is the one right over here, okay? User variables 4, and then click edit. And what you want to do, I have them already here. Let me see if I can close this. Okay. What you want to do is you want to add the following things. You want to add what I have here, okay? You want to add, so it says, then add the locations where you installed MinGW and MSys. If you use the defaults, then the locations are C MinGW bin and C MinGW MSys, and then whatever version it is that you have. Okay, I'm using 1, so you got to check to see what's in your path if it's the same. And then bin. The bin folder is where the binaries are stored. Okay. Okay. Then you say okay, and then you say okay, okay, and then okay. Now we can open up. Once you've done all that and you have it in your path, then we can open up. We're going to open up our. Let me zoom out a little bit here. Okay, open Visual Studio Code. Okay, and everything is the same here. Let me just make sure we fit everything on the screen. Split screen. Okay, so next thing we want to do is we need to have a folder. Let's do this. Let's go here, and I'm gonna make another copy. Say new folder. So say lab 1. And then we're just going to say -vs code. How's that? Okay? And what I'm going to do is I'm going to take these 3 files that we just made, make a copy, and stick them in the VS Code file. Paste. Okay? Because we're going to use this. But basically what we're going to do is run this. Okay? Run this project. So let's go open folder. And let's go to desktop. Let's go to this one. And just say select that folder. Okay. So what we need to do is we need to go. So we go open Visual Studio, then use the new C project extension we added. So to use this, what we need to do. Let me zoom this out a little bit, or slide it over a little bit. Okay. So what we're gonna do, we have to go to View up here. Command palette, okay, and then go down. Go to the next one. In command palette, we're going to type create. It'll already start. Create C or C++ project. I'm going to create a C++ project just because our code is. So now we're going to go. It's going to be in Lab 1 VS Code. Select that folder. Okay. Choose the location for the new project. Okay, insiders, ask me later. Okay. So this is my main function. None of these guys are yet included in my folder. Okay? This is my project. Okay, these guys are not yet included in my project. So what I need to do is I need to add them. Okay? So let's follow the steps. So create C++ and location, very important. MinGW has issues with paths that contain spaces. Ooh, okay, let's check. Make sure there's no spaces in the names of the folders, files, projects that you want to compile. There may be a problem getting to the desktop. So, what I'm going to do, let's go here. Let's save. Let's close. What I'm going to do is I'm going to take this. There's no spaces here, but I'm going to go in here. I'm going to say cut. Then I'm going to stick this in my let's see. I'm going to stick this in my C drive, right at the root. Let's see if I can do that. Okay, go to C. I may not have permissions to copy here. I'm going to have to get permissions. So actually what I can do is I could say, let me go right click, say new, folder, and just call it C projects. How's that? Okay, and then what I'm going to do is I'm going to stick this project in my root. Now I know C projects, there's no spaces. Okay, so I got to make sure make sure of that. What happened? Why didn't it? Did I copy and paste? It's good enough. Okay, I don't need this one then over there. All right, so let's go here. Delete this one. Yes, good. Okay, so this is where I'm going to be working from now on. Okay, so let's go in here, and what I have to do is I have to go into VS Code, but I have to open up the new directory, not this old one. Okay, so go in here, go File, Open Folder. I need to go right to C. Okay, so then go at the top, C Projects, right in here. This is the one I want to open. Okay, so first thing I want to do actually is, you see, this is main.cpp, right? What I need to do is I need to take these guys and stick them in the source folder. Okay, and then what I need to do is I need to change main.cpp. So this is main lab 1. So here I'm gonna have to change the name because it's gonna call main, right? So I'm gonna get rid of this guy. Okay, and then I'm going to change this one into main.cpp. Okay, and then I'm going to, well, I can just minimize that. So now I have in my source, I have main.cpp, which we wrote. Okay, I have parity.cpp, parity.h. Let's look at main. Main looks fine. Ask me later. I don't know. Okay, so let's take a look here. This is our code. Everything should work nicely. Our make file. Okay, this just keeps track everything that's in our include and in our source. This is going to work just like it does in Visual Studio. Okay, so that's what the make file will allow us to do. Okay, so that's fine. What do we got to do next? So we're going to get min.gw. Okay, we don't have any spaces. Everything's good. Next, add your files to your project. We just did that. When you're ready to compile, we go to the next step. So what do we need to do? We can go, there's a couple ways. You can do the command prompt, okay, in Windows, or what's nice is Visual Studio Code already has a terminal. So if you go to terminal here, say new terminal, we've got a terminal right here, okay? And we installed min.gw. Do you notice that? Okay, min.gw is already installed. So we have bash. You can also use the C compiler terminal. You can use the default shell, but I have everything here. What you can do, let's see. Let's go and look. So from the command prompt, okay, or right-click VS Code, use the built-in terminal. Okay, view terminal, or you can go to terminal here. Okay, there are two make utilities, one from min.gw and one from msys. Okay. The native make utility has been renamed to min.gw32-make, so it can coexist along with msys make. Okay, so there's two makes. Okay, so what do we need to do? It says the extension we added will automatically write the make file for us. That's the one that we added over here. Okay, this one that we added, the C++ one. It's already been project generator. Okay. All right, it will automatically make the make file. So to build the entire project, what we need to do is go where this already takes us to our root, okay, to where the project is, right? If you open up the terminal, it opens up to where you are. So if we want to run this project, okay, you see main, CPP, and everything. If we want to run this project, what we have to do, okay, is if we're here, all we have to do is go to the location of where we are and call make. Okay, so make clean will remove anything that's in bin. Okay, so bin right now is empty because there's no binaries, no executables have been made yet. But so if there was something there, you type make clean and it will delete any binaries that are in anything that's in the bin folder. Now, if we want to make the project, you just type make, press enter, and it will run that make file and build the project for us. And you'll look that in the binary here, now we have main exe. Okay, see how main is there? Okay, now you may have some errors. You might have permission denied errors. your antivirus might be blocking certain files. That's why I actually made a folder in the C drive that doesn't have any special errors that's required. I had Bitdefender. You may not have read and write permissions if you're in Linux. We'll look at Linux a little bit later, but you can follow these steps if you're stuck. This changes the permissions for folders. Okay, but if you follow my steps, you should be fine. I have an antivirus that's pretty picky, and I have no issues by doing what I just did. And these are the steps. If you're stuck and you have some permission errors, then you can follow the steps that I just did. Okay, so the sample output for this is so if I want to run this program, what I have to do is I have to go from here. I have to go to bin, right? I have to go to the binary. I have to go to this directory in order to run main. So what I do, let me lift this up a little bit. So if I want to do that, what I have to do is I have to go cd bin, because I'm in via lab1 VS Code, but I got to go into this subfolder. Now when I want to run main, I have to type main, okay, and then from there, what I have to do is I have to put my inputs, right? So what do I want to do? So it's going to be, let's try 1 1 1 0. Okay, this is going to be odd parity. 1 1 1 1 should be, I can put as many zeros as even parity, and then x 1 1 1 should be error, and push enter. Okay, in bash, if you want to run something, I could do main exe. Okay, so let's do, I could either type main exe or I could go ./main. Let's do this. X. There we go. For 1 1 1 1, parity on bytes is odd. 1 1, even, error. Okay, so you can see how this can work. This is the command line interface. Okay, the makefile is a topic for another time. Okay, we're not going to have time to go through this now. Okay, so we can actually do, if we want, if we have some time, we can do the same thing. Okay, if I close this, we can do the same thing in Ubuntu. Okay, so we have the same. So everything we just did now is compatible with Linux. Okay, so what I can do, let me go here and save. Okay, I'm gonna close this. Okay, and what I'm gonna do next is I'm gonna show you there's another file. Okay, this is in source. Let me go in. There's another file on eConestoga. Let me find it for you here. I'll tell you the name in a second here. We're in. Okay, we want to go to our labs, and whoops, no, this one right here. Okay. So the file is in eConestoga, and it's called VS Code and Terminal Compilation in Linux. Okay, so you're going to need to install Ubuntu in order to do this. Okay, so what are the steps to get this thing working? Let me just put this here. Okay, let me put this here. So the steps are download Ubuntu, okay, and install it. And that's okay. So download Ubuntu, download VMware Workstation Player. There's a free edition. You can use 14 or the latest. Okay, so what you can do, either go here or you can follow my link here or go to the latest edition. I know this one works for sure. 15 also works. So what you want to do is you want to go download Ubuntu. Okay, so go Ubuntu and then download. Okay, and you just download. Right now 20 is available. You can download this one. So you download the ISO, let that download. That's going to take some time. And then what you want to do is go to VMware. So VMware Workstation Player. You can get the latest and then just download. Okay, so download VMware Workstation Player. Okay, so 15 is available now. So you can go for Windows. Let me see something here. You got to be careful which one you download, because there's a free version, right? And then there's a paid version. There's a trial. let me see here. This one is, so yeah, you always have to check. Let me cancel this. This one looks right. I'm going to compare to the one that I have here. Just make sure you find the right. So if you take the link that I have here, say copy, and put it in here, paste and go. Okay, let's see. They have 14, but this might actually be the easiest way to go. Is it giving you? Let me refresh. We use cookies. That's fine. Add choices or not. Let me just, maybe they moved it. Let's just go to the downloads. Let's just see what they have here. Here's downloads. Yeah, here we are. So if you go right to here, VMware downloads all products, you can go to the, we want the free one, right? We just want to try it out. VMware Workstation Player, right over here. So download. Okay, and this is the one we want. This one I know will work. Okay, so what I can do, go here, copy, we'll change this, and then paste it. Okay, so we got 15. 15 should work. Okay, anyway, you download it, and then you install it. Okay, and once it's installed, okay, then we're going to install. So load VMware and click on new machine. So then what you want to do is once I have a really old version here of VMware. It's because my machine basically is a little bit older, so it doesn't. So what you can do is you can go here. You can say player, right? New virtual machine, and then here you're going to choose the ISO that you downloaded. Okay. Go to next. You name it. You put username and password. I'm not going to install anything here, but what you want to do, follow these steps here. Okay, you go to the one you downloaded, put your name, put your virtual machine name, choose a size. I'd split the virtual disk into multiple files. If you customize your hardware, you can actually change what your virtual machine looks like in terms of like how much memory you give it, how much space you give it, etc. Okay, and you can modify, you can customize. Like right here, I've already installed, but you can customize it later. You can edit your virtual machine settings to give it more RAM. You can give it more processors. You can make it faster. Okay. Then when you're ready to install, you hit finish, and it will guide you. It's a guided process. It does the installation, everything for you, and then you're ready to go. Then you're going to log in to Ubuntu. Okay. So we're going to go here. Okay, you got to let it boot up. So once everything installs and it's all ready to go, then you can log in. Once Ubuntu is up, you're going to log in, and you're going to install. We're going to log in and install Visual Studio Code. Okay, and then we're gonna have that. We're going to install that project generator the same way. Okay, so we're going to follow these steps. Okay, so you may need to pause the video to install Ubuntu, install VMware. Well, install VMware, then install Ubuntu on your virtual machine. Once you're done, you can come back. I'm gonna let this run. It's just loading up. There's a couple things running on my machine at the same time here. So go in Ubuntu 20 or whatever version you have. Log in with your password. Okay, what I'm going to do is I'm going to grab that folder. Where is it here? It's in my C drive. So C projects, right? This is what I want. I want this guy. Okay, and let me go here. What I'm going to do is I'm going to grab this and put it. It's not letting me, is it? It's not going to let me do it. It's not letting me do it. So we're going to have to do it one at a time. Okay, we'll follow the steps exactly as they're shown here. Okay, so first thing is you need to install VS Code. So how do you install VS Code? You click on Ubuntu software, whatever store you want. It depends. I have Snap Store, and either one will have it. Just look up over here. Look Visual Studio Code. Okay, let it load up here. It's downloading the latest catalog. Okay, let's give it a second. And anyway, what you're going to do is you're going to install VS Code, and then with VS Code, we need to install that project generator. Okay, so let's let it download. And okay, so up here, usually it's one of the options, actually, one of the more popular options, but it's not here. So I'm going to click here. Okay, let me open it up a little bit. It's already installed on my machine, so it's going to be a little bit. Let me see here. Let's put it like that. Okay. Okay, so just click on the search here, this button, and then just look Visual Studio. Just push enter. It'll find Visual Studio Code. Okay, and then you just click it. Mine is already installed. You just click install and install it. Okay, so just to show you that, once you have it installed, if you want to install it on here, just click on this guy, look for Visual Studio Code, then right click it, and then just say add to favorites. Okay, and then what it'll do, it'll put it over here for you. Okay, we're gonna click it. What I want to do is I need to put this again. I need to put this in an area where I have permissions. So where you're guaranteed to have permissions is in your home folder. Okay, within whatever you put there under Documents. If I right click, I can make a new folder here and just say lab 1. Okay, and then create. Okay, then what I can do is take this guy. Okay, just so because I have it open, I'm gonna just. I know it tells you here when to do it, but I'm gonna take everything inside source here. Okay, except for the output files. I need main.cpp, parity, and parity.h, and I'm gonna basically drag and drop here. It's not letting me. Yeah, no, it did. Okay, it should let you do it. That's one thing I like about VMware. Okay, so now I've copied everything from my Windows computer, so I don't need this open anymore. Okay, so we've got these. Now I got to keep following the steps. Okay, let's close this and put this over here. Let me make some more space here. Okay, no, I actually want. Let me take this out. I want to see and show you the steps, so we'll keep it like that. Okay, so open folder, and it's got to be in a location that you can see. Go to Home, go to Documents, Lab 1, and this is the one you want. Say OK up here. Okay. All right, so we have this. Next thing we need to do is do the same thing we did just now. So go here, go to C, right, and then C++, project, and it should start showing right here. There we are. Click install because we want that. Okay, so we need this guy. We want this one installed. All right, and then next thing we need to do before we can actually start making the projects. Okay, I'm going to close this. We need to install all of these dependencies. Okay, we need to install make, GCCG. They may already be installed, but we want to do it anyway. So one thing we can do, we can either do it from here, from the terminal here, okay, from down here, or what I could do, let me just let me make this smaller. This is actually going to have bigger text for you to see this. Okay, so here we're going to install make, GCC, G++, and anything we may need. It may already be installed, but we want to make sure. So how do we do it? You may not understand these commands, or you may understand it, but don't worry, just follow along with me, okay? So sudo apt or apt-get, you type update. This updates your repositories. Put the password you made when you created this VM. Okay. Upgrade, I'm not going to do. You don't have to upgrade your your distribution. That'll take a long time. Sorry, distribution upgrade would give you an upgrade. You don't really have to. You know what? Let's cancel this. You don't need a dist upgrade. Okay, let's save that. So then, if you need to upgrade anything, if it shows you that there's something, how many things can be upgraded, you may want to upgrade. I don't really need to upgrade these things, just to save us some time. So what do I need? I need build essential, which is make and GCC, and then I need libpop-dev. Okay, these are the dependencies that we need in order to install things. So let's say sudo apt install build essential. It's already installed. Right, it says here we're automatically installed, no longer required. We don't need to auto remove if we don't want to. It's already manually installed, or it's already installed, so that's good. Then sudo apt install lib popt-dev. Make sure. Let's see, following, installed, no longer, unpacking. Okay, it's already, okay, it's going to install them. No, it doesn't. Oh, setting it up, process. Okay, that's fine. Anyway, we know for sure. Now, to make sure that everything is installed, let me just clear. So now you can see, let's see what version of GCC we have. So GCC-V tells you that's the version. It'll tell you that it's version, I have version 9.3.0. I can say G++. Now you can -v or -- version also works. The same idea. So here is 9.3.0, and then we can say make, just for V. Let's see, we have 4.2.1. Okay, perfect. Okay, the next thing we can do, and I didn't show you this before, but if you want, we can install Git. I highly recommend that you start learning how to use Git. So we say sudo apt get install Git. Now for this lab, I know that, okay, it's already installed here. I'm not going to show you Git just yet. Just for this lab, just make sure it's installed. All right, so now we've got this done. Everything that we need, all the tool set that we need is installed. So let's go back to Visual Studio, Visual Studio Code. This should say Visual Studio Code. Okay, and now we're going to use, this extension just like we did before. Okay, so we go View, Command Palette, and then we need to create C++ project. And then we need the location, so it's going to be in Documents, Lab 1. We want to create it here, and then we got to move these things there. Say OK. Okay, and now we're going to move everything into the lab. So let's go here. Go here. We need to move it into the folder because the make expects things to be inside expects the files, right? These files that we have 1, 2, and 3 to be inside our source. So let's go. So go in here. This main was generated already for us. We don't want that one. Okay, we actually want the one that we produced. So let's go back to Lab 1, and we're gonna copy these guys into the source directory. Not the make file, but everything else. Okay, and now the make files is looking in here for all the source files. So we're actually good here. And this are auto updated for us. So everything is working the way it did on the Windows side, so we are good to go. All right, so we've made the project. We've got the make file. It's already done for us, just like a regular project in Visual Studio. From the terminal, we can now do our compilation. So this guy right here, notice it already took us right to Lab 1. So we can do our same thing we did before. We can say make clean. There's nothing in the bin folder, but it just shows you what it does. It removes everything from that folder, okay? And then we make our file. Say make, Okay, so now there's stuff going to be in our bin, right? The main is going to be in there, right? So we need to navigate. Let's go cd bin. Okay, you can say ls to see what's there. Main is there. To run main, you go dot / main space, and here's where you put your inputs. So let's go 1 1 1 1. Okay, 0. Okay, this should be even. 1 2 3 should be odd, and let's put an error of a 1 1 1 1 1. Okay, push enter. Okay, and if I raise this up a little bit, you can see it better. And zoom in a little bit. Okay, so now you can see it works too. We have even, we have odd, and we have error. Okay, so that's it. We've basically, and now you can end the program by pushing enter. Okay, so we've done both the output, the sample output. If you have any issues, you know, there might be some errors. You can edit the code to remove some warnings. If you have these issues, there's some steps here that I put for you. But just to keep the video from being too long, anyway, this is everything that you need to know. Thanks for watching, and I hope you enjoyed the video and you learned how to make files in both Windows, under Visual Studio Code, in Windows and Linux.